So we're going to first write it in expand and simplify, and then we're going to express as a single power, and then we're going to use the exponent law as we did prior to that. We're going to see what is the difference in the answer. So I have a cubed divided by a. In the expanded format, you guys remember that I write it as a times a divided by a. So what happens when I simplify? What would I have left? So 1 and 1 cross, and then I'll be left with a squared. Okay? Now if I'm going to use the exponent law, what does it say when I'm dividing? What do I have to do with my exponent? I keep the base and I subtract the exponent, right? So I have a3 minus 1, which is a squared. Did I get the same answer if I did it expanded format or the exponent? Okay. Let's do the same thing with the second one. So I have a times a times a divided by a times a. If I want to cancel things out, I'll be left with a. And if I want to subtract using the exponent law, so it's 3 minus 2, which gives me a. Got the same answer, correct? If I have a3, so a cubed times a cubed, it all simplifies. So if everything simplifies, what do I end up with? 1, right? So if you divide something by itself, the answer is 1. If I use the exponent law, 3 minus 3, which is a to the power of 0. You see that my answer here is a little bit different, right? If I did the exponent law, I got a to the power of 0, but if I did the simplification, I got 1. Do you think I've done a mistake here?
No, because it's still equal.
So if I do a to the power of 0, give me any number for a. A could be any number. Give me a number for a. 2. Can you on your calculator do 2 to the power of 0, or 5 to the power of 0, or 10 to the power of 0, whatever you want your a to be? On your calculator, do that. What do you get when you do that? 1, right? No matter what your base is, no matter what your number is, when you raise it to the power of 0, it's going to give you 1. And this is one of our rules. This is the 0 rule. And if you look here, no matter what the number is to the power of 0, you're going to get 1. Okay? So, and the reason for that is because technically I'm dividing something by itself, right? And that's going to give me 1. Also, it's going to give me a to the power of 0. So these are equal to each other. Okay? So a to the power of 0 equals to 1. That's one of our rules, and that's called the 0 rule. We're going to talk about it later. Now, a cubed divided by a to the power of 4. So a times a times a divided by a times a times a times a. If I do my simplification, what do I have?
Negative a.
What do you mean negative a?
Wouldn't it, like if you divided equal, I don't know how to answer.
We'll talk about that in a second, the negative, but if you were going to write this, how would you write it?
A.
No, a is in the bottom, right? What do I have left on the top?
Nothing.
We'll talk about that in a second.
There's nothing else.
There's 1 on the top over a, right? There's nothing on the top. There's nothing left, so that's 1 over a, right? So if I do my subtraction, I have a 3 minus 4. So what's 3 minus 4? Negative 1. So that's a to the power of negative 1. Now again, you see that my answer and my simplification, they're not the same. But we're going to look at a rule, what's happening. We're going to look at a pattern. We're not going to do this one. So And this one is a repeat. So let's look at this one. A times A times A over A times A times A times A. So if I'm going to do the simplification, we have 1, 2, 3. So what do I have left? 1 over A squared, right? So I have 2 A's multiplied at the bottom. So that's 1 over A squared. Let's do the simplification. The exponent law. 3 minus 5. What's 3 minus 5? Negative 2. Let's do one more and see if you see the pattern. I have A times A times A all over simplify. What would I have left? 1 over A cubed. Okay. Now if I do the exponent law, what am I going to get? Do you see a pattern here? Sorry, that's negative 3. Do you see a pattern here? Denominator and the denominator. Okay. It's more like the reciprocal. Okay, it's not the opposite operation, it's the reciprocal. Okay, so what we have here, you see that if I have a to the power of negative 2, these should be exactly the same answer, right? Because I'm following the rules. I'm not changing the rules. Okay, I'm getting 2 different answers. That's it. But these 2 answers are exactly the same. They're the same value. Okay, which means if I write a to the power of a negative 2, it's the same thing as 1 over a to the power of 2. If I write a to the power of negative 3, it's the same thing as 1 over a to the power of 3. They're the same. One with a negative exponent, one with a positive exponent. Now, we should not leave our answer with a negative exponent. We should always have our answer with a positive exponent. So when we do the exponent law, because that's the easier format, right? It's easier to use the exponent law. I'm going to get a negative answer. Once I finish, and if I have a negative exponent, then I have to change it to a positive exponent by doing the inverse. Okay? So what you have to do, if you have a negative exponent, you should flip the base, make your exponent positive. Okay? So flip the base, make the exponent positive. We're going to talk about this when we're writing the rule. What do you think the answer for this is going to be? Using the exponent law, what would it be? A to the power of? Negative 4. Now, if I want to write it as a positive exponent, what do I write it as? 1 over a to the power of 4. Okay? So, why am I flipping? If you look at this a, this is your base is a, anything is divided by 1. If there is no division, it's divided by 1, right? If I flip my base, so flipping this, that's going to become 1 over a, and then my exponent is going to become positive exponent. Does that make sense?
Is that the same with the absolute value?
The absolute value, you're talking about the number that's negative becomes positive, not the exponent. Okay, zero rule. What does the zero rule says? Anything to the power of 0 is equal to 1. So, a to the power of 0 is 1. Give me any value you want for a. 300 to the power of 0 is 1. Anything to the power of 0 is 1. And we've seen it. We've seen it. Like if I have this, for example, right? So I have 2 times 2 times 2. They cancel. So I'll be left with 1. If I want to use my exponent law, it's going to be 2, 3 minus 3, which is 2 to the power of 0. They are equal to each other. Are we okay with that? So, the negative exponent law, it depends on what I have. So if the negative exponent is on the outside, so let's say if you have the whole thing here, whatever, right? And then you have a negative 2 outside, then you want to do it first. You want to flip first and make that exponent positive. But if your negative exponent is inside, so let's say if you had this, let's say you had this, right? You don't want to flip first. You just do your math, do the usual, right? If you're doing division, you're subtraction. If you're doing multiplication, you're adding your exponent. Do the usual. And if your answer at the end has a negative exponent, then you flip. Okay? So, apply this law last. I'm going to say this except in the case of if you have the negative exponent outside, right? Then you do it first. So, apply this law last. Take only the base with a negative power. And switch its placement that's placement so for example, if it's a numerator, you're going to put it in a denominator and vice versa. And change the power to positive. So let's say I have this. How would you write this as a positive exponent? Which one has a negative exponent? The x. It's in the numerator or denominator? Right now. Is it in the bottom or the top? Top. The top. That's the numerator. Right? Denominator. What's the denominator for this one? 1. Anything that doesn't have a denominator, it's 1. Okay? Which we don't write that usually. Now, since x to the power of negative 4 is in the numerator, what I need to do is I need to switch it to the denominator because that's where it is right now. It's in the numerator, it changes its position, right? From the numerator to the denominator. So that means that's the same thing as writing y squared over x to the power of 4. Okay? So I switch it from the numerator to the denominator and I made it positive exponent. Does that make sense?
So the y stays on top.
Yes, because the y has positive exponent.
So if both of them have negative,
Then both of them will switch and I would have 1 in the numerator, right? So if I had this, for example, right? Both of them would come down to the denominator and I will have 1 in the numerator. Yeah.
If the y was negative, would you just keep the x on the top and put y at the bottom?
Is the x negative or is the x positive?
Positive.
If the x is positive, you keep the positive in the numerator.
It doesn't matter what side it's on.
Doesn't matter. Well, the side doesn't matter. It's just which one has a negative exponent. You're going to bring it down. Okay? Let's say if I have what do you do? Bring the y to the denominator. Leave everything else in the numerator, right? So that's going to be 5x squared z over y to the power of 1. I don't have to write that. Right? I'm bringing the y to the denominator because that's the one that's negative. How about if I have this?
so you only put the b negative 2 down.
Okay, so I'm going to bring the b negative 2 to the denominator. And I keep the c negative 3 in the denominator.
No.
I bring that one back up because that's a negative in the denominator, so it's going to switch up. And then the b, because it's a negative up, it's going to become positive in the denominator. Okay? So they will switch their position if they have a negative exponent. So you're going to work on the questions that you see with example 3. And if you guys look right here, the next page, this is a lot of examples that I want you guys to practice. Actually, this gives you all the rules. Okay? This right here, that page here. So these are a lot of examples from 1 to 38. You can do all of this. The answer for them is at the bottom of the page. Okay? So today's job is to do these questions. I want to see them done. I want to make sure that you are practicing because they're going to be worth a lot of marks when it comes to the test. Okay?